Hey guys, welcome to Math for Kids by a Kid. Today I'm going to talk about the third way to solve quadratic equations. It's by using the quadratic formula. Let's look at this example. We have to solve x squared plus 4x minus 3 equals 0 by using the quadratic formula. So before we even begin this, we need to write out the quadratic formula, and this is what it looks like. X is equal to negative b plus or minus the square root of b squared minus 4ac, and this is all over 2a. So now let's look back at the equation. I'm just going to write it out again down here. We need to find out which of these numbers are a, b, and c. So we're going to put the general form of the equation. So ax squared plus bx plus c, and we're going to find out which values are which by looking at this. So you can see that there's an invisible 1 in front of the x squared, and this matches up with a. This 4 matches up with b, so b is 4, and then c is negative 3, so we got to keep in mind the negative, so we're adding negative 3. So now let's plug these numbers back into this quadratic formula. So x is equal to negative b, and that's negative 4, plus or minus the square root of 4 squared minus 4 times 1 times negative 3, all over 2 times 1. From here it would be x equals negative 4 plus or minus the square root of 16 plus 12 over 2. Now for to simplify it even further, x equals negative 4 plus or minus the square root of 28 over 2. And like I said before, if the radical can be written as a mixed radical, then we should do so. So 28 is really 4 times 7, and this is 2 times the square root of 7. So this is x equals negative 4 plus or minus 2 times the root of 7 over 2. And now, if we were to look at these three numbers, we can see that they divide by 2. So this can become x equals negative 2 plus or minus the square root of 7 and over 1, or we can just write it like this. Let's say you're given an equation that looks something like this. You would expand both the left side and the right side, and then move everything on the right side over to the left side so that the right side is 0, and then do the solving from there, find the values of a, b, and c, and use the quadratic formula. Now let's look at an equation like this. You have 1 over 3x squared minus 3x plus 1 over 4 equals 0. So what's different here is that we have fractions as the numbers, as values of a, b, and c, whereas before they were just whole numbers. So what we're going to do is we're going to make it so that all three terms have the same denominator. And to do that, we need to find the least common multiple, the lowest common multiple, which in this case is 12. So we've got to multiply the denominators by the number that makes it 12. So the 1 over 3 will be multiplied by 4, and the negative 3 will be multiplied by 12 on the bottom and top, and the 1 over 4 will be multiplied by 3 on the bottom and top. And now let's rewrite the equation. You have 4 over 12 x squared minus 36 over 12 x plus 3 over 12 equals 0. And now we notice that all of these have a common factor of 1/12. So we can just remove that so that we get just these top numbers. So that turns out to be 4x squared minus 36x plus 3 equals 0. And then from here, we'd find the values of a, b, and c, which a is 4, b is negative 36, and c is 3, and then use the quadratic formula to solve for x. Now there's one part of the quadratic formula that's very important. It's called the discriminant. I'm going to show you where that's located in the formula. So I'm just going to write it out again. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So the discriminant is this part here. So the radicand of this radical part. And if we know the discriminant of a quadratic equation, we can determine how many solutions it has and which method we can use to solve the equation. So this is a basic diagram. If the radicand, or the discriminant, is negative, it has no roots or solutions. They mean the same thing. If the discriminant is equal to 0, it has one rational root and can be solved by factoring. If the discriminant is positive and it's a perfect square, there are two rational roots and it can be solved by factoring. If the discriminant is positive but a non-perfect square, there's two irrational roots and cannot be solved by factoring. You can also think of these inequalities when deciding how many roots there are to a quadratic equation. So if you want to solve a quadratic equation using the quadratic formula or completing the square, you can do it whenever you'd like. But you can't always use factoring to solve a quadratic equation. You need to find the discriminant first, and if it's 0 or a positive perfect square, then you can use factoring, but otherwise it won't work. Thanks for watching, guys. I'll see you soon.